start with our featured session that's going to be about working with geometries and shape files in Spotfire, starting at the very beginning of how to create them in geographical software. To present that session, we have Senior Customer Success Manager Neil Kanungo, who will start off, and then we'll have our Q&A session. Over to you, Neil.
Thanks, DJ. So today I'm going to talk about GIS and creating custom shapefiles. Before I go into it, I just want to give a quick overview of what we're going to cover. In Spotfire, you may have seen some of the shapefile features, such as I'm showing here with different geometries. And you maybe are getting these shapefiles from somewhere else in your company or online. But I want to show you here today how you can create this yourself. So to start, I'm going to give a quick background, and then I'm going to go into the demo. So GIS is Geographical Information Systems. There's various different products out there for working with GIS. Today, we're going to focus on QGIS, and this is something you can download online for free. A shapefile is an Esri standard. Esri is a company, and it's a standard from the 1990s, and it's actually a collection of different files. I mention this because when you create a shapefile, you'll often see these different files created on your desktop or on your computer. And so all of these files together kind of create what is this Esri standard of a shapefile. There's three mandatory files, the SHP format, SHX, and DBF. You might also see a projection format and these spatial index features. One thing I want to mention just real quickly is that projections are quite important. You can see here there's different rectangular representations or cylindrical representation, but there's different kind of distortions to this. And these are going to be the way the points that you create in the shape file and how they are mapped to the actual surface of the Earth or whatever you're projecting to. There's also different coordinate systems. So you may find that you're plotting different points on a map and they're slightly misaligned. You may have it in a different projection or coordinate system. So it's something to check in on. The shapefile itself is consisted of polygons, lines, or points. So you can see here, this is a polygon. There's a river here, which is an example of a line. And then there's these wells here, which are example of points. Each of these will be their own shapefile. So you won't create one shapefile that has all of these together, but rather different shapefiles for each types of geometry. There's very interesting applications you can do with this outside of just traditional maps. You can do floor plans for facilities or warehouses. You can do seating charts for arenas or concert halls. You can do maybe human body or for medical applications. You can even draw some of this stuff into equipment diagrams if you want your data to be mapped to specific equipment. So you'll be able to download QGIS for free at this link. In this demo, we're going to use QGIS 2.18. A newer version is out, but QGIS shows this as the most stable, so we're going to use this one for our demo purposes. So with that, let me open QGIS, and let's get started. So when you open QGIS, you'll see a kind of project window. I don't have anything open right now. So the first thing I can do is create a project, and I'm going to just save this project onto my desktop, and I'll just call this demo project. Once I'm inside my project, I want to be able to add my image. So I have from Google data sources, I've taken a floor plan of the San Francisco airport. So to bring that into QGIS, I'm going to add a raster layer. And I'll go into what rasters and vectors are in a minute. So here I have this raster layer inside. And what I want to do is I want to start digitizing. Digitizing is the process of creating the polygons that, or lines or points. So to do that, I'm going to create a new shapefile layer. And like I said, I can only use a point, line, or polygon. So here, I can also create some attribute fields, which I'll explain in a minute, I'll show you in a minute, but to explain it, what they are is you can essentially create text, number, date fields, and you can create these attributes into it. This is really similar to what you're seeing here. With these geometries, you're going to see different attributes associated with it. So I create a category attribute, and let's create maybe a name attribute. add to field list, and here we go. So here I'm going to create a new folder, and I'm going to call it demo shapefiles. And I'm going to call this polygons. Sorry, I set this as a point, so let me change this real quick and do that again as a polygon. Apologize. So I'm going to create category, and I'm going to create a name. Here, I'll just call this polygons 2. So now here I am on my map. So one way that GIS is, these GIS applications can be a little bit different than just drawing as you would in Microsoft Paint or something, is that you have to actually turn on and off the editing mode. So I'm gonna hit this pencil, and now I've turned on the editing mode, and I can use this to create a new feature. So the feature being polygons, I can start to create a polygon right here. Give it an ID of 1. I'll call this a restroom, and this is the men's room. Now, I said I would mention what rasters and vectors are. When you zoom in here, you'll see this background can start to get pixelated. It's because it has a finite resolution. Vectors have an infinite resolution. No matter how much I zoom in, it's not going to affect the resolution. This is mathematically determined, so you can continue to go in and out and not be faced with some of these issues. I'm going to draw another polygon here. I'm going to make this 2, also a restroom and women's room. Now you can see there's a gap here. If I zoomed out, I may not be able to see the gap, but as I zoom in, there's a gap there. So one way to avoid this is in the settings, you can set a snapping option. And I highly recommend you do this if you have a lot of adjacent polygons. So I'm going to set snap to vertex and segment, and I'm going to select 2 map units. So now you can see it's going to start snapping here. And if I make a point I don't like, I can hit the delete button or the backspace button and it'll undo it. So I come up here, I can now hit all of these points, and to complete the polygon, I'm going to right click, and when I right click, here I go. Now, what I just did when I typed in restroom and women's room is I assigned the attributes. So to view the attributes, I can click this button right here, and I can see the attributes table. If you want to change this, you have to have the editing mode on as well. If you don't have the editing mode on, you won't be able to change any of this. When you make your changes, you can hit the save button here to save the attributes table. Or when you're digitizing, to save something, you hit this button right here to save that layer. So that's how you save the layer, and this is how you save the project. So if I want to do the borders here, keep in mind I got to do them separately, so I'm just going to do this really quickly. I'm going to create a line to show boundaries. Let's see, I'll call this actually boundary name. I'll call this just name. And I'll save this as boundaries. So to create a line, you'll see this button looks a little bit different. This time it's now a line and not a polygon shape. And I can do the same thing here. And create different polygons, or sorry, lines. So I'm going to save this, and now I'm going to show you how to bring this into Spotfire. On my desktop, I wanted to show you the shapefiles we created. So you'll see in here that there's 6 different files that were created for each shapefile. So we got polygons 2, polygons, and boundaries. The one we want for Spotfire is just a .shp. So I have Spotfire loaded up, and I can simply just drag and drop this in, and it'll start opening this boundaries. I'm also, while I have this open, I'm just going to go ahead and drag and drop in the polygons. It'll put it on a new tab because it's a new data table, but I'll clean this up in a second. So first thing you'll see is a little error here. The map visualization Spotfire by default it creates a layer that's a map layer, and we're not going to use a map layer for this. So we're just going to go ahead and remove it. So we have the boundary here. If we want to edit the features of this boundary, we go into layers, and then we go into settings, and you'll get a different dialog window. And this is where you choose all your properties of this layer as it's almost like its own visualization, like you would do with the bar chart or pie chart in Spotfire. So we can change the appearance, we can change the line weight, we can change all, the colors, things like that. So I'm just showing this for effect. So now I'm going to add a feature layer, and I'll go in a second what these different layers are, but I'm going to add the polygons in. So another point is a coordinate reference system. You have the map chart here, and then you have the coordinate reference system. You have the coordinate reference system within the layer. So the layers, coordinate reference system, and the map chart one. You want to make sure that those match. So I've added the polygons in. I can do things like turn on labels for the name. And I can also adjust in the layers, I can adjust the interactive, which layer I want to be interactive. So if I want polygons to be interactive, I can choose that one. The other thing I can do is I can add a image layer in. And an image layer we're going to add is the actual map shapefile, or sorry, not shapefile, map image. So the properties for this image show 4914 by 5062 pixels. That's the dimensions. So I'm going to browse, I'm going to add this file, and I'm going to set the extents. You can see here in the background that it's drawing the map and everything all kind of off. So what I want on my image is the top left corner is going to be Y high. So I'll make that 0. And the bottom left corner is going to be X low. So I'll make that 0. So for my Y high, I'm going to use the dimensions. I'm going to use a negative version of this. So negative 5062. And for high, I'm going to use, for the X, I'm going to use 4914. And one thing to note is that you can actually do this automatically with IronPython. You can do this automatically with IronPython and R. So if you have a lot of images, you can kind of be reading them off a directory maybe, or dynamically changing them if needed. But now here you can see that I've aligned it. So we have this all kind of put together here. I also want to point out that one thing to check if you're having issues here, if you go to edit and column properties and you go to polygons, if you come down to properties on the geometry, you want to make sure that map chart type, the column ID, type ID is geometry, and you want to make sure that content type is application X and WKB is well-known binary if you're having any issues. So with that, I'm going to show you a more complete analysis. I don't want to take your whole morning while I sit here and digitize the whole thing. So this was what I had shown you at the beginning of the presentation, where you have different geometries you can kind of select. So I took this whole digitized area, and I mentioned the word digitize importantly because if you're having issues with some of this, you want to Google the term digitizing in GIS, and you'll be able to find a lot of help. So I have this map here with all these geometries, and I have some survey data, some public survey data about some visitors that visited this SFO airport. So here I'm showing the visitors' responses and the overall map. I can change and look at the different categories here because I set those as attributes. So different accessibility. I can see where there's art, where there's restaurants, retail, security, or even just put them all on the map if I want to kind of look at it all together. What I have here is I've created a KPI that shows the different boarding areas, that's what these letters are, and their average rating from a visitor for those boarding areas. Below, I have, on a scale of 1 to 5, these visitors rated things from signage and escalators and elevators and artwork. They rated various things, with 5 being the best and 1 being the worst. So those that were rating 4 to 5, I have considered promoting certain features, and I've categorized them as promoters. And those that rated 1 to 2, I've considered detractors over here. At the bottom, I just have some general comments. So this is just the general comments that some of these visitors left. And I have some filters here. So if I want to see, for instance, the frequent flyers, I can hit this filter, and I can see now that my KPIs over here are changing. So we can look and see where the frequent flyers, what they didn't like. And I can click this, and I've created something that will show these circles here, the number of respondents that have said this. And this is arranged by gate, where basically the visitor is heading. So the visitor is heading here. 4 of them didn't really like the restaurant options. I can click here and see what the restaurant options were. Also, when I click here, I can see that general comments they left for the whole survey, 3 of them said they couldn't find the type of food they wanted or the product in the store. So we can really see how the restaurants and retail shops are affected here. So I can click retail as well, and these are the retail shops available. One important thing to note is that these customers may be taking different paths in. So depending on their transport method, if they're taking the BART or the air train or they're parking, they may be coming in from different entrances. And I'll go into that a little bit later. So let's see, I'm going to keep this on retail. And I've created a separate view, a terminal view, where you can actually see these respondents across all these different terminals at a kind of a zoomed in view. So you can zoom in within these if you'd like. You can hover over these and you can see what these are. So that's a women's room. You can click it if you wanted to. So you can see these various parts of the terminals and boarding areas and zoom in. And one neat thing I did is I actually made my title bar just one big button. I kind of used a little visual trick there. So I could click this and it'll run an IronPython script, which will then reset the view of all of my maps. So if you didn't want to use this visual trick, you could just make a standard button to run an IronPython script. And by hitting it, again, I can reset the view of all of my maps.
So in the terminal view, can you show us how you were actually able to show the individual terminals instead of the full map view? So did you use data limiting or some other technique?
Sure, there's a couple different ways to do it. One way is by setting the trellis. So you could trellis, let's see if this will work the right way. You could trellis by maybe like the boarding area, and it'll split it all up. There's different layers here, so you're seeing them all together. But if you do a trellis option, you won't be able to control the zoom individually. So if you have like maybe a factory floor plan or something, it might make sense, but for something that has as much detail as this, it may not. So one option is a trellis. And then the other way you can do it, and the way I did it here, is actually by limiting the data. So I went to layers, and for each layer, I just did a limiting expression. So I just went boarding area G here, and so it'll limit that whole shapefile. And so I created that for each of these. So
Very
that's
neat.
yeah, that's the way you can get control of zooming. Yeah.
And then you go to the actual data that we got after creating the shapefiles. So I think it was GIS review.
Mm-hmm.
Yes. Now on this page, can you explain the column geometry? You know, like the shapefile is all of those files and their metadata stored together. So the geometry column, can you just go through the column properties and explain how this is different from other columns in Spotfire?
Sure. Yeah, this has different properties, like you said, as a column. This is kind of coming from the attribute table. And one interesting thing is that it will bring in the X-min, X-max, Y-min, Y-max, and also the center. So the mins and maxes, like this is going to be a Y-max and X-max, this top right corner. This will be an X-min. So it'll have that in there. The geometries, if you want to see a little bit more about it, you can go to column property. So you can look at, these are like strings over here, integers, reals, typical for any other column or data set. But what's going to use for geometry is a binary. The format's, again, a well-known binary.
So I just wanted to show the users this particular content type, application/XWKB. This is, and then map chart column type ID geometry. This is how Spotfire understands non-standard data formats. So it's entirely possible, and it's a trick that not many people know about, it's entirely possible for you to have a column full of images, and that's going to be binary type, but this is a column full of geometries that can be plotted on a map. So this is a column geometry. So these two, content type and map chart column type ID, these two properties that you see are what allows Spotfire to understand that you're bringing in shapes, you're bringing in something that's not a text or a numeric value. We have a question on chat where Dylan is asking, can you use the polygon to mark data? I see it done, but I'm unsure how to set up the relationship. So right now, our data is in the same table where we have the geometry. Let's say your geometry and your data are in two different tables. Then you could set up. So right now, Neil has showed the method that we are currently using where our data and geometry is in the same table. Now, let's say your geometry and data were in two different tables. The simplest way to do it would be to use the ID tag that we created, and with the ID tag, just perform like a link or a join or a column matching or column relation in Spotfire, whichever is the most suitable way of doing that. So instead of defining the categories in GIS, we could have had a separate column of categories as tags and just use the marking and joins in Spotfire to attach all of that data to that column type or to the ID.
That's right. So if your column or data set, your transactional data or whatever, it has an ID number that you can join with the IDs in your GIS table, in your shapefile. That's one way you can make this kind of interlinked. What I did with mine was, since every visitor was going to a gate, and my geometries, I have geometries that have a gate associated with it, I joined on the actual gate, and that's what makes these kind of, all kind of work together in mine. So.
Can you say, Neil, did you do it in Spotfire? Can we see the data panel source view to understand that a little bit better?
Sure. So, I mean, I have, this is a data I've loaded in, and the data table view I have, for this one, I have boarding area, and if it's a gate, I actually joined on these gates that are present. So what this is going to do is it's not going to tie survey responses to other geometries because I didn't want it to.
And let's look at the source view for the survey data, because you've done a ton of interesting transformations. So I just wanted to show the user that in Spotfire, when you bring in your data, you can use the data panel and you can use all of these transformations and settings to perform these actions. And those actions are going to be linked to your data source. And then if you click on the little settings icon, so that's going to allow you to move your data in and out, and you can actually change these transformations that are embed. So the edit transformation, I believe, came out in one of the later versions, I think after 7.7. And this is pretty handy because now if you need to change something that you did on step number 3, you don't need to delete the whole thing and redo it. You can just go to that particular step and do it. So we end up using the data panel quite a lot, and I would definitely suggest is one of the most useful things about Spotfire.
Yeah, just want to make sure users are aware that shapefiles have some limitations. You get a 2 GB file size. The length of field names is 10, and the number of fields is 255. So if you're having some larger projects, one unique thing about Spotfire, you might want to look into this and make sure your tools can use SQL Spatial. Spotfire is one of the few tools out there that can link to SQL Spatial. And what this is actually SQL Server, Microsoft SQL Studio. So just within Microsoft SQL Studio, this is a screenshot directly from there. And you can create these geometries and store those in there. And that'll get you outside of those limitations I spoke of. This is also an advantage on enterprise governance level. If you have a lot of shapefiles, maybe I have this airport and something gets moved, or maybe a restaurant becomes a retail store and gets changed. If you have thousands of users, them all having to go and update their shapefile or have access to this file, it starts to become a governance nightmare, kind of like managing multiple Excel spreadsheets. A better solution would be to have a database, SQL Spatial, a Microsoft SQL Server, where you can have a SQL Spatial database, and that can be, the changes can be controlled, and that would be reflected automatically in all of your analyses. The other thing with Spotfire is that you have the advantage with tear, so you can actually create simulations. One thing that we didn't have a chance to go into in this session, but maybe we'll in another session, is using tear to dynamically calculate these paths that you can go through the airport. So you could see where visitors are entering from, if they're coming from parking, what gate they're going through, and if they even pass through enough restaurants and retail stores, because they could have very different experiences depending on where they're coming from and where they're going. There's also some great examples in our community of using contour plots, using R packages for GIS to calculate these dynamically is really interesting. There's also, if you have a ton of geometries and you don't want to draw them, there are ways to convert the rasters to vectors. And there are ways to convert AutoCAD DWGs directly to shapefiles. So you can Google into that, or even learn online. I did a Coursera class on GIS, which I thought was pretty good. We also have some great resources online. Peter Shaw, one of our senior data scientists, has some great content on geoanalytics and is very active in this space. There's a really rich page on the community here, and there's all kinds of data functions and things available for you to download and plug and play with. That's all I had, DJ, so I'll hand it back to you.
Thanks, Neil, and yeah, shout out to Peter. It was his original technique to create these GIS files and bring them into Spotfire. Everyone, we are on chat and Q&A and also picking up your questions from there. So if you've not seen chat, definitely give it a look. I am sending you the link for Community Exchange, where you can see the Spotfire templates and download some of the stuff that we showed with the contour lines and density heat maps and all kinds of cool stuff with Geo. So we skipped introductions today. Divya Jyoti Rajdev, I go by DJ, and I run the Q&A session of Dr. Spotfire. Sometimes I run the featured session as well. Our team has expanded a lot, so shout out to the extended team, customer success management, support, and professional services and education, everyone that's been chipping in, and of course the data science team. If you have any questions, we pick up the questions from community.tipco.com. So post your questions with hashtag Dr. Spotfire. If you have sensitive data, then you can also email the questions to us. You can also tweet us questions with the hashtag Dr. Spotfire. For emails, ensure that it's actually, you actually have some sensitive data. Otherwise, it's faster to get answers from community because that's a larger working to get your questions answered. Before I start, I wanted to tell you about a couple of brilliant pages to get started with Spotfire. One is Essential Spotfire Analytics. This is basically a bird's eye view of all different resources and pages that have to do with Spotfire and analytics. It's not exhaustive, so I would still suggest going through community, but it definitely has, if you're a new user, it gives you a good high-level picture of everything. The second page that I highly recommend is the Customer Success Center. That's more of a newsletter style of a page, so you see what the latest and greatest articles and webinars and events are. It's a nice page to just bookmark and check every once in a while. Now, moving on to the questions, we have another question on chat, which is, after you know which columns you want to relate, you can go to Edit, Data Table Properties, Manage Relations. That will relate the two tables together. That's absolutely correct. So let me just show you that. So Data Table Properties, I have these two tables that are almost entirely the same. So I can go to Relations, can manage a relation, add a new one. So I will take Candlestick data and match it to Candlestick 2 and match it by ID. Okay, click OK, and ensure that comes up in column matches. Sometimes if the columns are named differently, you might have to go in manually. But once you say apply and you say OK, I can have division on one table, but now I can actually choose my X and Y values from the other tables. It's a very neat little quick way of joining two tables together. So thanks, Neil, for giving that little snippet. There's a question about the difference between column matching and relations. Going to be slightly more in-depth, but very simply, column matches lets you use the column from another table in filters, and column relation is just, visualization. So that's a one-line answer, but we can discuss it in more detail next session. So thanks for that. The first question that I received for this week was getting started in how to create a candlestick chart in Spotfire. So a candlestick chart is quite similar to a box plot. So let me show a box plot. The difference is that in your box plot, you can't really configure your lower value and your inner fence, upper fence, and your upper value. This comes from percentiles and quantiles in your data. Whereas candlestick charts are usually used for something like finance. So think about a stock market. So your fence would often be, your boundary would often be the opening, and then this would be the closing. Or if your market for a particular stock closed lower than it started, then you would identify that with the color. And your upper values would be the highest of the day, and your lower value would be the lowest of the day. You're actually not looking at quantiles and percentiles at all. You're doing it quite manually with providing the 4 values that you need. So for things like this, what I suggest is that you submit it on ideas.tipco.com because it does not exist as is in the tool right now. And now we have the link for ideas.tipco.com. Often product managers will pick up the popular ideas from the ideas portal and implement it as tool features. It's a very good way for us to find out what the users want to see in the tool. Now, having said that, I'm going to work with you and create a workaround and see the limitations and possibilities with that particular workaround. So the workaround can be to use bar chart, and with the bar chart, create a stacked bar chart and define the upper and lower control limits or upper limit and lower limit. So the data that I have, it has an ID column, which is just categories, categorical. Then I have a start, I have an end, and it's very nice that I can actually see how my data is distributed in this histogram. Then I have the lower limit and I have the upper limit. So I am going to insert a bar chart. Now you can immediately see that in my bar chart, I plot the start and end in the stacked way that I want to plot it, simply because this is wide type data. So in order to convert it to tall type of data, I'm going to select these two columns and unpivot. And that gives me two columns with start and end category and value. So in older versions of Spotfire, when you did this operation, you would have to solve it, like you would have to rename it manually. But in newer versions, it gives you a necessary name for the category and value. If you still want to change it, you can go into the data panel and rename it to something like measure or something else. So now let's change this to category. Actually, let's change this to ID because honestly, that's my categorical column, and I'm going to color it by category. And on my y-axis, I want my measure. So if I just make this transparent, now this starts to look like the type of box or the type of candle that you would expect in the box plot candlestick plot. Now, in order to go in and add the error bars, I am going to use my upper limit and I'm going to use my lower limit. Let it be sum, it doesn't matter, and I'll show you because we have only one value per ID, so it doesn't matter. But otherwise, you might want to think about the aggregation. As you see, nothing really happened. So let's go again, diagnose it, error bars, vertical, sum. And now you see that even though you get the error bars, it doesn't quite show up. And that's because you can't do an error bar on a stacked bar chart. But if I change it to a side-by-side bar chart, then I lose the start and end value that I had configured. So that's not quite what I was looking for. So this is something I've already submitted as an enhancement, but I just wanted to show you that there are multiple ways of doing the same thing in Spotfire, even though you might not always know which method is going to be successful. The other thing that I have done is I've basically taken the same visualization, the same data that I started with, but instead of pivoting the two columns, that is, instead of pivoting the start and end, I pivoted all four values. So you can see that now I have the category as all four values, and I have the value as the measures of all four of them. And then even though this does not look exactly like a candlestick chart, but it fulfills the same function pretty well. Let's go in and decrease the bar width. And now you see that it's essentially the same type of functionality that we were looking for. And I've used the same trick where my lowest value, I've just made it transparent. So this is the gap between start and low value. This is the gap between start and end. And this is end to upper value. So you might have to be a little bit more creative with your data, but it absolutely works. Like there are multiple ways to solve the same problem. The second question that we had was a visualization question. We have a new addition to the team, Vinod. He's going to help out with IronPython questions. I'm very happy to share with you that in Dr. Spotfire from this session onwards, you're going to see a larger number of IronPython questions with solutions and explanations. So I started with one question for this session. From next session, we'll have a greater number of those. So this particular question is asking that they're working on a certain Spotfire version. They want a new page through an IronPython script, and they're wondering if on that new page they can set up the height and width of each visualization. So the first comment that I have is that sometimes it's hard to understand what you're trying to do without a concrete example. So for example, I don't know if they want to set up the page width and adjust all the visualizations according to that, or if they have a visualization layout and they want to set up every single one of them to have a consistent height and width. So I'm going to go with the assumption that they want to set up the height and width of each and every visualization. Here's the script, and I'm going to show you the script live in action, but let's just go through it before we see an example. So we've defined a width document property, and that has some value. So that value gets extracted into this, the width parameter. Similarly, we have a document property height, and the value of that gets extracted into this parameter height. Then this script assigns the height and width to that visualization, and then actually changes your visualization size to do that. So by default, you have fit to window. Now, fit to window over here is 1200 by 1080. That's the resolution that the original DXP was created in. If you have another resolution, then that's what the fit to window parameter would take. So over here, we've imported the size attribute, the size namespace, and on the essential resources within product documentation in the API doc, you can see exactly how this importing works and what different namespaces are there, what are the attributes, properties, functions of all of them. So now we've assigned it the height and width. And over here, this is where you are doing that formal assignment. And this is where you're actually changing it and setting it up. So over here in fit to window, from the pages, you are extracting visualization area size and giving it fit to window. And then this is essentially what goes into this particular one, because this is where we set up. So now when you do area size, it looks at this particular attribute that you set up. So that's what the script is. Now let's see how it works. So I have a very simple page set up where if I go into document properties, and if I go into scripts, this is the script that I have. Let's go in and edit that. So you can see that exactly the same script, and you have a couple of different versions of IronPython that now you can use. So a lot of the newer libraries that worked with Python 2.7x now will work with IronPython, so that was very exciting. It is taking the visualization as an input parameter, and that's basically the plot that you have on the page. So for example, you have this particular selection. If I had more, I could always provide that as input. So let's say, okay, and these are document properties width and height. So the names matter. If you have a different name over here, and if you have a different name in your script, that's going to create an issue. And then we just have a button that's calling that script. So now this button is calling the script that we set up. And over here, so if you see on our parameter for the script, we only provided it the visualization. What if you had multiple pages and you wanted to define that particular visualization as well? So that selection would happen over here. So right now, I'm just going to say okay. And right now, I'm at full screen. So my full screen can be 1920 by 1080, 1200 by 1080, whatever your device size is. And then let's change it to 1200 by 1080. And you can see that it resizes each visualization to that size. Now, this is because the question was structured to have this requirement where you resize each visualization. You might have to go in and make a few more additions if instead of each visualization, you wanted to auto adjust the visualization aspect ratio to the page. So this is how this works. Now, here's the interesting part. If I click on it again, it toggles, because if you remember how our script was set up, it doesn't matter what the value is over here when you do it the second time, because the second time is actually the toggle operation. So that's just something to be careful about. And now let's see what it does when you have two visualizations. And I'm duplicating the same visualization because this is essentially what I passed in as a parameter. So now if you recalculate the size, you can see that it recalculates this entire section because these both are my parameters that are going into the script. So that when you're trying to automate things through IronPython, there's always a little bit of these gotchas that you have to watch out for and test against. But otherwise, it fulfills the requirement pretty well. I won't have time to cover the last question, but I very quickly wanted to show you this particular page that I couldn't cover last time as well. So we had a question about dplyr and tidyr that it gives you unexpected errors. So it's a known bug that's been fixed completely in 4.5, but even in 4.4, it works. TER version 4.4, it works as expected. Let's say you don't want to upgrade, then you can get the last compatible dplyr package from this particular repository. So normally you would use the CRAN default repository, but if you want the last compatible version of any of these tidyverse packages with TER, download it from tran.tupco.com/TER and TER version. In this case, it's 4.3. Thank you so much, everyone, for your questions. I will not be able to cover everything on chat, so please post it as feedback on the community questions or on the Dr. Spotfire page, or post it as a separate question with the hashtag, and we'll cover it next time. Look forward to your feedback. Thank you.